Hokie dokie. In this problem, they give us three charts relating to species A, B, and C, and they give us some statements regarding those charts, and we're looking to see which ones are true. So let's work backwards. We're going to start at number 3 and sort of define a few things as we work through 3, 2, and 1. So number 3, species C reaches full growth potential sooner than species A. Full growth potential. What does that mean? As we're looking at chart C, we're looking at these values. They're increasing until they hit about here, which is at time 10, and they kind of start to level off. They're all around 97-ish. So it's like all these big jumps, kind of a smaller jump, but then it evens out for the rest of it. 10 would be the time of its full growth potential. So 10 is where C hits its full growth potential. So now let's look at the, analyze the chart in the same way for species A. So it's increasing, and then 193.98 is close enough to 194 to say that at 15 is where this species levels out or hits its full growth. So I would say because species C has its full growth potential at 10, A has it at 15, C does reach its potential sooner than species A. So that is a true statement. All right, number 2. Species A grew at a slower rate between 2 and 3 than species B did between 10 and 15. So there's a couple pieces here to keep in mind. They first say species A grew at a slower rate between years 2 and 3. So the very first thing we need to do is find the rate of change of species A between years 2 and 3. So how do we do that? That's just another way of asking us to find the slope between years 2 and 3 for species A. So we'll do y2 minus y1, treating the function values as our y values and the time values as our x values. So we have y2 minus y1, which would be 11.79 minus 5.77, all divided by x2 minus x1, which is 3 minus 2. I'll go ahead and break out a calculator for this. We'll do 11.79 minus 5.77, and that'll give us 6.02. Divided by 1 is just 6.02. So then they say that rate is slower than species B between 10 and 15. So we repeat that process. We look at species B, and we go to 10 to 15, and we're finding the slope or the rate of change between those two values. So we start with the function values, 256.69 minus 34.76, and we're dividing this by 15 minus 10. So, all right, so using a calculator, we have 256.69 minus 34.76, and we divide that by 15 minus 10, or 5, and we get 44.39 if we round. So, again, they claim that species A grew at a slower rate than species B. Well, this was the rate for species A. This is the one for B. So 6 is a much smaller rate than 44. So that will also be a true statement. That is a slower rate of change. Moving on to statement 1. If a grower wishes to harvest trees at 20 years, then the grower should plant species B. Okay. So what does that mean? It relates actually to the full growth potential that we talked about in that third statement. And so I guess a way to look at it is like however many years they want to harvest trees at, that should be also the full growth potential, or like the time it hits its full growth potential. So as we're looking through species B, it's increasing, and then increasing for one last time. And around time 20 is where it levels out at around 291-ish because it's like 290.7, and that's close enough to 291 onward. So it's around time 20 or 20 years where it levels out, or where it hits its full growth potential. So that is, the same, that corresponds to where the grower wishes to harvest trees at that many years. Like that's, I don't know, they're related. So that's pretty much it. So that is a true statement because it hits its full growth potential at 20. All right, back out the eraser. Let's see that H is in fact our answer. All these statements are correct. Feel free to check out the other example I will work out as well.